I talked about public goods and how they should be provided. Let's now have a look at how public goods are provided in the market before briefly turning to some policy interventions. Let's assume we have an economy with n identical agents, and they all seek to maximize a utility function U, which is a function of private consumption W, and the public good that is provided G. G is privately provided, everybody contributes a little bit. G bar is how much others provide, and small g is how much you yourself provide. And then total provision is just a simple sum of these two. Now, of course, if you provide public good, and that means that you have less private good, because part of your budget goes to providing the public good. So this is what the utility function looks like. Now let's have a look at the provision of the public good. So in this graph we plot G bar, how much others provide, against G, how much you yourself provide. And U is an indifference curve. Now the indifference curve slopes upwards at this end and fairly steeply. So why is that? Well, if you're going to increase your G, your supply of the public good, then you're going to take a cut in your private consumption, and that means that others will have to make up by increasing even more of G bar, so as to compensate for your loss of private consumption. So at this end, the indifference curve goes up and goes up fairly steeply. Here, the indifference curve slopes down. Why is that? Well, at this point, you don't supply any of the public goods yourself, and others supply actually fairly little, so you're unhappy with the state of the public goods provision. So you are willing to step up the plate, and you're going to increase your supply of the public goods. And even if others respond by supplying a little bit less, but of course their reduction must be smaller than your increase. So this slopes down, but very gently. Now, if the indifference curve goes down at this part and it goes up in this part, then it must reach a minimum somewhere here. The exact numbers are, of course, arbitrary. So that is the basic graph. Now, this is an indifference curve, so let's look at a bunch of indifference curves. U1 is greater than U0 because you have more of G and more of G bar, so you're just happier, right? And it just goes up in this way. And the further you move into this corner, the happier you are. If the others provide a whole lot of the public goods, then there's no minimum, and the indifference curve just goes up, right? So, what is your best response to how much others supply? Well, that is where the indifference curve reaches its minimum. So the best response, how much you would supply of G in response to what the others do in G bar, is this particular line here that goes through the minima of the indifference curves. So that is what you would like to do. Now, the supply of public goods is this curve here, because everybody is the same. Everybody's supply is the same, and because there are n minus 1 others, the slope of the curve between G bar and G is this curve with a slope of n minus 1, and that comes from the fact that G bar is simply n minus 1 times G. Everybody is the same in this economy. Now, what do we learn from this graph? The optimum is, of course, where supply equals marginal utility, and that is in point E. The Market equilibrium is where supply meets demand, not marginal utility, demand. And that is in point N, where the best response function equals the supply function. And what you see immediately is that G star, the optimal supply, is much smaller than the equilibrium supply Gn, right? So that is why the market under provides for public goods. And the next thing that you see is actually that you shift from utility level U1 to utility level U2. So it's not just that the market undersupplies, but also the market is inefficient in the sense that you're not in the optimum, not in the Pareto optimum. You could have done better. And because everybody is identical in this economy, everybody could have done better, right? So everybody could have increased their utility from U1 to U2. So that is what theory says. The provider gets only a fraction of the benefits of her investment, the rest go to others and therefore invest less. Same on the consumption side, the consumer feels only a fraction of the losses imposed by her decisions, the rest because it's not rivalrous, the rest being felt by others and therefore consumes more than she should have. This is theory. We see the same in the market out there in real data. What you're looking at here is fishing off the coast of Argentina. These are fishing hours as counted by nowadays every fishing vessel has to have a little thing on board that counts where they are, that tells the authorities where they are, but also counts how much they fish. Just a little computer that signals what they're doing. That's what you see here. And these are satellite pictures that essentially see the fishing vessels because of the lights that they have on board. Right, you need light to fish and navigate, so you can actually see those ships from space, and that's what you see displayed here. So just a pretty map. By the way, show this red line that you see here, and this red line that is reproduced here, and here is the boundary of the exclusive economic zone. To the east of the red line, anybody can fish. To the west of the red line, you need permission from the Argentinian authorities to fish. And it's perhaps most visible in the nighttime, the night lights pictures, that to the east of the boundary you see a lot of fishing vessels, and you also see a lot of fishing hours, but the visualization isn't quite as stark. So that is how the things look on a map. If you then draw it as a graph, this is the number of hours of fishing per million square kilometers. So this is an indicator of fishing intensity on the high seas when there's no restrictions versus the exclusive economic zones where you need a permit from the authorities to fish. And you see just this sharp drop in fishing activities. And the same is true for the night lights from these vessels. You see a very sharp drop from the open access resource to the privately, or in this case publicly owned resource. So this is not just theory. We can actually see this in the data. This is not just theory. We can actually see it in the data. So the problem with public goods is that they're underprovided and overconsumed. And then the question becomes, what can a policymaker do about this? In order to answer that question, we need to realize that there's also common goods and congestible goods. sort of a mix between public and private. With common goods, the problem is non-excludability. There's rivalry in consumption. If one fishing vessel catches a fish, then another fishing vessel cannot catch the same fish. But nobody can exclude them from fishing on the high seas, because the high seas are not owned by anybody. And the solution there, the preferred solution, is to essentially create excludability. That is the problem with the market. And one way of doing so is to give each fishing vessel a quota. You can only fish so much, and that then creates a property right over the fish that is yet to be caught, but still it is theirs. And in order to allocate those fishing quota properly, you want fishing companies to trade their quota. So that is one way of solving the problem of common goods. For congestible goods, there is excludability, so that is not the issue, but there's non-rivalry in consumption, so people consume too much. But if we're talking about a road, then if everybody consumes too much, if everybody drives too much, then of course you get traffic jams. So the problem there is overconsumption, and the way to encourage less consumption is to increase the price. Now the market will do that because of the non-rivalry in consumption, but the taxman can. So the preferred solution there is to tax people according to their use. And if use gets too much, then the tax goes up, and that discourages further use and would reduce demand. So that is how you would solve problems of congestion. With public goods, they're both non-excludable and non-rival, but need to be supplied nonetheless. And the only practical solution is to provide them from tax revenue, to let everybody pay tax according to whatever is deemed fair and proper in this particular jurisdiction, and use the tax revenue to provide the public good. Lindahl would immediately object and say, no, it should not be paid from general taxes, but really it should be a user-specific tax. But that is very hard to estimate and would sort of immediately run across all sorts of democratic principles about taxation and equal treatment before the law and equal treatment for the tax by the tax authorities. So really, just provide it from the general tax revenue. That's a practical solution here.